before. We had multiple things happen. We had our curve. Some curve. And we did call it A. And we did call it f of A. We didn't call this x. We called it something else. Because, does this help you? When we were doing the distance, we called this
The distance.
A plus h, right? And so this distance on the horizontal becomes h. And what's our vertical rise between the points? What's that vertical? I think so. I think it's this. Alright. Again, this would be a tangent or secant line. If I want to be a tangent line, what has to happen to h? I have to take h to 0, and that needs a limit. And it's still rise over run. And a plus h minus a, remember from before, it just becomes h. Alright? And this is the slope of the tangent line. What's the slope of the secant line between these points?
Well, the top would stay the same.
The top would stay the same?
Plus, or it would be over.
Wouldn't it be just the same as this, except
h wouldn't be 0.
h wouldn't be 0. The tangent line would have some distance.
Yeah.
Are we all clear on this? The only difference between secant and tangent is the limit. Because we want the bottom to get to 0. Alright. So if I want to find from multiple points, let's talk about the last problem. The last problem we dealt with was something like this with y equals x squared. Alright, or f of x equals x squared, for some value of a. And if I wanted to find a range of a's, I don't care how many. We don't want to plug in 1 and then do it again. Plug in 2, alright? So if I plug in a plus h, you all agree we get a plus h squared minus, everybody agree it's a squared all over h. Alright? Again, you will quickly learn, and I'm not going to take the time to do Pascal's triangle. You also probably should have this point memorized by now. When you square a binomial, you're going to get that triangle. What's the cool thing that happens right now? And you remember this from the homework like 2
You
more.
can take an h out.
Well, back up. Something else first. First
Oh,
thing,
get rid of a squared. Yeah.
everything that doesn't have an h goes away. Guess what? That happens every time. And all you're left with is stuff on the top that has an h and an h on the bottom.
When we get really good in practice, that we're going to have to write that out.
When you want to write it out, make sure everything goes away so you don't have math mistakes.
Okay.
Because these are long-winded. Does everybody agree this then reduces to this? And if you plug in 0 for h, right? Now
It's just 2a.
it's 2a. So think about it. This equation,
So
2a.
2, 1, 2, 2.
So what's the slope? We know the slope at a, if a is 1, we knew the slope was 2 of the tangent line. What's the slope at a equals 2? 4. What's the slope at, what if I go to x value of 10 and I ask for the tangent line? It's 20. Think about that. That's the rate of change. That's how fast that tangent lines up. At 1, it was sloping 2, which is fairly steep. At 2, it's sloping 4.
Do that because it's x squared.
It's x squared. It grows x. Exactly. It's squaring itself. All right.
Like if you
The
got
power form.
so it got to be like x squared is 4a, right?
And at a equals 4, it would be 8. Yep.
Right. And if it was y equals x4, wouldn't it be 4a down there?
Oh,
or no?
No, and I'm going to make you do that. It gets other than that.
Okay.
It gets nice thought, but yes.
All right, because Pascal's triangle is
You get
different.
a plus 4
Yeah.
to the 4th. You're going to have 4 terms. So there's a lot more stuff happening. All right.
Yeah. Yeah.
And this works, and it always, always, always has cancellation and h is remaining. All right. And this is again a tangent line. All right. This is a tangent line. And we care about tangent lines because we're real interested in how fast things are changing. All right. If it's changing, all of a sudden, if instantaneously not changing at all, that's the top or bottom, right? We talked about this. If it's up or down on the stock market. You gotta picture curves in your head. Thinking to yourself, boy, I'd really like to know when things were happening, right? Positive, 0, negative, 0, positive, 0, negative, 0, positive. You know, if you buy it here and you sell here, life's great. And that's probably truthful. That's what Mr. Anderson does. I can't take the time to do the other. Wouldn't it be a lot smarter to buy, sell, buy, sell, buy, sell? You get this value and this value. You get all the extra times. Almost impossible to do on stock.
Because right now you have just that one line.
You really can't do it, okay? I'm not saying that, but there are times in life when you know these things happen in manufacturing, in distances. Every situation can be math and calculus. This is the world. Marine biology. Can you do it in college, Charlie? I don't know biology. Agriculture. Math at all. Alright? It can be math. Now, sometimes equations are excessively difficult. Like, it's bad math.
So right, nothing is you just map what you predict.
Oh, we're going to predict. We're going to predict. And what do we know? Average velocity. Average velocity is a secant line. What's instantaneous velocity? Boom, baby. Tangent line. And we put a big asterisk in your notes. This is what we want to use. This is what we want to practice. Even when it's easier to do it the other way, just plug in numbers immediately. We want to become good at doing variables. Does that make sense, everybody? Luke, that means don't be lazy. That's it.